like 1996. Wow, it was a long time ago. And then you must be joining it from the Redmond, Washington, right?
Yes,
And
yes.
then I studied about his career, and he closely worked in a with a real world problem and like a real world product, which is like Microsoft the SQL Server, so which is like a great success as far as I know. And then he will share his perspective about how it is going to be like being in an industrial lab and working on the real problem, still like making a contribution to the academic community. That is going to be great. And then we have also Dr. Clifton from the Purdue. I assume that you're joining from the Indiana. And yes, he also has like a long list of CV and a very interesting journey along with his career. He was in academia. He was in like a MITRE, which is a great like a security research, like a public company. And then he worked for the NSF and going back to the Purdue. That was really, really kind of very the diverse like experience that he can share for a long period of time, along with his successful like achievement from the both academy and the industrial like areas. He is going to be the chairing the session, so he will lead the discussion for today's the discussion today's panel discussion. And then we also have a Dr. Gautam Das, who is joining from the Arlington, I guess, and then very close from the where I am right now. I'm in Dallas. He also has like a diverse like the journey throughout his career from the Microsoft Research Compact Corporation, and before actually he was also in academia and University of Memphis. And then he is currently serving as an associate dean for the research from the UT Arlington. And then he is a distinguished university chair professor of the computer science and engineering department of UT Arlington. And lastly, we have Dr. Wei-Shin Koo. He is now like a professor at the University of Urban. Also, he is serving as the program director at the NSF, National Science Foundation, and SCIENCE and IIS program. So I'm very happy to host great panels for this session. And then I think we will have like a different rounds of the paces for the discussion. First, I will like ask each panel to introduce briefly about your backgrounds, your career paths, in about 5 or so minutes. And then like we will, after that, we will move on to the next phase. We have prepared like a general question that I will ask you, each of you. Then we will like give the floor to the students or the like audiences who has like questions, especially in this time of like pandemic. There should be a lot of like concerns and questions because this is something unprecedented. So we all wonder what is going to happen next. So I hope that we can earn like a interesting insight from the big minds from the research community. So okay, so I will for next. So I will ask Dr. Straji, can you take the floor?
Yeah, one quick question.
Yes.
When we are given the instruction, we are told that like there will be 2 separate kind of rounds. One is to introduce ourselves, and the second round was to talk about the advice, etc. Do you want us to like split it in that way, or we should just tell everything we have to say right now and then Q&A afterwards?
So I think so. First, I ask you to briefly introduce about you so that we can have your background. Then I will like go for another round for questions.
Okay, got it.
Okay.
Thank you.
Great. Okay.
Can you switch to my sharing or yeah? Okay, good. Can you see my screen?
Not yet. Would you please?
Yeah. Okay. 1 second.
Actually, we may be if your screen is showing you.
Okay, now it is coming.
Okay, I'll put it in the presentation mode. So if you can't see my screen anytime, let me know. Okay, I finished my PhD in early 90s from Stanford, and it just so happened I got reminded that I did graduate at the time of a recession at that time. So it is reminiscent, although seems much deeper. I have the benefit of being the oldest guy here. So that's the only thing I can tell you about myself that's interesting compared to the other panelists. All other panelists has a much more interesting diversity in their career path. I don't. I only worked in industrial labs. I worked at HP Labs, Palo Alto for 4 years. And then since then, I've been at MSI Redmond, Microsoft Research Redmond for the last 24 years. So that's pretty boring from a diversity of the career. The research areas wise, I work in the area of query systems. Specific areas I have worked there is auto tuning, including auto indexing, query optimization, and approximate query processing. In fact, some of the approximate query processing was done with Professor Das, who is also on this panel. Data preparation, data exploration. The data preparation has a lot of data cleaning and other data transformation aspects. Data exploration is really how to make sense of data and find things in data, and more recently in the cloud resource optimization. I have served in primarily 3 roles. The one role is individual researcher, and that's how I got started, and that's what I still continue doing. The second role is, is as a manager of a group, which is called the Data Management, Exploration, and Mining Group at Microsoft Research. And in that role, there is about 15 people who I work with closely, who have expertise not just in core database systems, some even in operating system and distributed systems, some in algorithms, and now a few in machine learning. I had the opportunity to serve for a few years as sort of a portfolio manager, where I have oversight of a broad area of systems, and that included operating systems, networking, distributed systems, programming language, and so on. And during that same time, I managed an incubation lab for a few years. And it's interesting, there are trade-offs as you become a research manager. And as we talk in the second round, I'll reserve some comments on it. And most of my perspective would be in the next round is about industrial labs. And let me just defer presenting this slide now. I'll do it in the second round.
Thank you. Would you, Dr. Clifton, can you also introduce yourself as the next?
Sure. And let me take over with a screen share here and see if I can get this up. If you can let me know, you should be seeing.
Yes, we are seeing your screen.
Okay. So I'm surprised by Surajit saying he's the oldest here, because I'm actually going to start off with some things I did pre-PhD, because those actually had a big influence on my post-PhD career. I started off at Tektronix in 1979, where I worked for 3 years, but basically about 1.5 years full-time equivalent over the space of 3 years. This was in a corporate R&D environment, actually a research arm that was doing support for a lot of development, and gave me quite an experience with what's involved in computing. I mentioned because even though I did not have a PhD at the time, I was working with PhDs, everything from kind of helping people prepare publications to kind of building real systems that people were demoing. And so it was very, a lot of experience in the corporate world. And then I had experience in a real corporate research lab. Not sure if any of you recognize this picture. It's a building that is no longer there, at a campus that is no longer there, but this is where System R was invented. This is the
San Jose
lab. It's gone, yeah. But this is, all the people have moved up to the Almaden Research Center. wonderful experience of kind of the real high-end frontline corporate research. And it was a very, very exciting time. I was working with the highly available systems group. And this convinced me to go on for a PhD. In fact, I think my words when I was asked after getting my master's, would you like to come back here, were, yes, I would, but not without a PhD. I realized there was a lot that I needed to learn to really fully contribute at a place like IBM Research. Post-PhD, I thought about going back to a research lab, but decided to go to a academic position, and spent 4 years at Northwestern. Wonderful environment, had great students, very exciting times, and really experiences the differences between a university and corporate research, what it was like to be in a faculty role. And I could see, while I enjoyed it very much, there were some things that, that just, it wasn't working out for me very well. And so after 4 years there, I was considering looking around, looked at other things, and our conference chair, Dr. Thrasingham, brought me into the MITRE Corporation. She was leading a database research group at the time, and brought me in as a data mining person back in the mid-90s, very early days of data mining. And I can first say that Bhavani was a wonderful mentor, and being in this interesting environment. MITRE is a nonprofit corporation that does contract work almost entirely for branches of the federal government. And so this was a new type of experience. It had some of the same things as corporate research, but some other things that were like a university. Learning about, grants were not, became, and getting funding became much more critical when that was your entire salary. And oh, by the way, you can't go to all the places that most people go to. Very wonderful learning experience. I can't thank Bhavani enough for that. But after a few years there, I realized I missed having students. The PhD students I'd had were wonderful. And so after a visit to a partner of MITRE, the Sirius Center at Purdue, I applied and kind of rejoined the faculty ranks at Purdue University, where I've been now for almost 20 years. And again, this was a, wonderful experience, something that was done with the full support and acknowledgement of people of MITRE all the way along. And, so it's kind of, again, returning to the faculty ranks, and I'll be able to talk later about some of the differences. And I actually had a kind of fourth sector, which was when I worked at the National Science Foundation, really working in a government service position. And again, this is something very different, not so much doing the research as supporting and enabling others to do research. So this has been quite a journey, and lots of new things, lots of new places, lots of new things to do. And that is the new data science building at Purdue that will be built in over the next couple of years. So it's been a very exciting career, many things happening, and I'll be able to, in the next section, compare and contrast some of the differences in this.
Thank you, Dr. Clifton. So yes, because you brought up the NSF, so I'd like to invite Dr. Wei-Shin Koo, who I believe is currently working as a program manager at the NSF. Would you take the floor, Dr. Koo?
Oh, sure. Hi, everyone. My name is Wei-Xin Ku. I'm very happy to have this opportunity to serve as a panelist of this esteemed PhD symposium. So just a brief introduction about myself. So well, even Dr. G mentioned that he wanted me to say something about NSF, but I think I just briefly start from my PhD experience and Auburn University than my current job. So I did my graduate studies at the University of Southern California. So I got both my master's and PhD there, and I graduated in 2007. So, and after that, I joined Auburn University in Alabama. So I started as an assistant professor, then promoted to associate professor, then full professor. So I've been there for around 13 years. Then I had the opportunity to join the National Science Foundation last year. So actually in February last year. So this is my second year as rotator program director at NSF. So I use the word rotator because I'm not really a permanent federal employee. I'm still a state employee. I'm still a professor at Auburn University, which is a state university. But at NSF, I basically do the same thing as other program directors. So I run panels, I review proposals, and I join meetings for NSF. I also attend conferences and basically use the chance to introduce people what we do at NSF. So that's basically my career experience so far. So basically two major components, Auburn University and NSF. So as you can see, other three panelists, they are more senior than me. So I think they have more colorful career paths, career experience. So mine is kind of a bit simple, but that's what I have so far. Thank you.
Thank you, Dr. Good. But I think but your experience must be most freshest, so maybe much more helpful. Okay, so
well,
next.
I'm happy to tell you guys more about NSF, maybe during the session.
Yeah, actually, we are more interested about, like, a lot of people are interested in what is going to happen in the midst of like a pandemic from the government funding side. Maybe we can talk about it later, more about that.
Sure,
last but the least, Dr. Gautam Das from the Arlington, Texas. Yeah, please take the floor.
Okay, so I'm going to share my screen. Let's see how it works out. So I'm not getting to see my. No. Are you guys seeing anything?
No, except you. You're
okay.
Handsome.
Show all windows. Okay, here we go. That thing was hidden somewhere below. Okay, now what? Can you see something?
I think it.
Yes.
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 Okay, so I'll run it in presentation mode.
Okay.
Okay, so I have a few slides to introduce myself. Now, these slides are borrowed from some other presentation I had done where I had to introduce myself using a bit of more time than what I have here. So I'm going to go over some of the slides quickly. I really don't want to, go on and on talking about myself, but there are a few points that I think are going to be useful that I will hope to communicate through this. So this is the first phase of today's presentation. So quickly, education. As you can see, I'm probably of the same equivalence class as Surajit in terms of my age. 78 to 83, I did my bachelor's, and that's an old black and white photo of me. All good things come to an end. This is IIT Kanpur in India. I actually did programming with punch cards. I don't know how many of you know what this thing is.
I know.
84 to 90, did a PhD, master's and PhD from University of Wisconsin, Madison. And, I'm going to talk a little bit about my diversity, both in career and also in sort of research topics. So at that time, my PhD was nothing to do with databases. It was on computational geometry. And that's again a picture of me from the 80s in my, I guess, my room when I was a graduate student.
Wow.
So yeah, I mean, all good things come to an end. Employment, so I've been out since 1990, so 30 years, and I've kind of moved around quite a bit. I first started as a professor. Again, I also graduated during the time of recession, and I was a theoretician. Not that easy to get jobs. I got a job at the University of Memphis, with some very good graph theory people. So that was good, and that's me, in the early 90s. And towards the end of the decade, the other part of my sort of professional life was actually in Surajit's group. Well, it was started with Osama Fayyad's group, but eventually Surajit took over the group, and I was at Microsoft Research for about 5 years. That's when I was starting to do research in databases, data mining. And since 2004, I've been at University of Texas at Arlington, and that's a picture of our engineering research building at UTA. Some of you may have visited, but if you haven't, I would love to have you host you here. In terms of other opportunities to spend time, I've also had shorter stints at other careers. So in 98 to 99, about a year and a half, I actually was a visitor in a development facility. So I was actually an engineer trying to build some software for this nonstop SQL product in Tandem. So as you can see, I have a lot of diversity, but fortunately, I very quickly realized that I'm really bad at that. I hastily retreated to a more, research-oriented, environment, which was Microsoft Research at the time. I also had an opportunity to go to a sort of a government kind of research lab in 2011 to Qatar Computing Research Institute. Again, a couple of years there I took a leave from UTA to go there. So you can see that I've kind of covered industry, corporate research, product development, academia, and also, I guess, government research labs. So I don't think anybody in this group here has the kind of diversity that I have.
You're the best, buddy.
Surajit, you're trying to say something?
I said you're the best in this regard.
Okay, all right. Well, best and diverse are two different meanings.
Well, best in the diversity sense. Yeah, sure. Yeah, I mean, that's what I mean.
All right. So, let me talk a little bit about my research. Again, I'll be quick. I don't want to bore everybody. So initially I was a theoretician, nothing to do with databases. My PhD thesis and my first part of my University of Memphis career was all on graph theory, computational geometry. I worked on something called graph spanners and proximity problems. And those of you who are interested, I can share later on a little bit about some of the beauty of these problems and why I found them exciting at that time. But towards the sort of the late 90s, I kind of got interested in data related problems. How do you explore and search large data sets? And also data mining was getting very interesting at that point. So I started dabbling in data mining, and that's how my research interest shifted. And right now I'm kind of doing more of this. And this is a sort of a picture of my lab, DBX lab at UT Arlington. We do all kinds of work in core data problems as well as application areas. And this is a picture that was taken a couple of years ago at SIGMOD in Houston, me with some of my alumni and my current research team. I'm also very proud of them, and many of them have gone, not many, I mean, I haven't had a lot of graduates, but many of them are doing quite well. They have got employment in some of the major corporate labs, as well as engineering companies, and also in academia, as you can see from this. So that's where I am right now in my career. Very recently, I have also had some administrative appointments. So again, more of the diversity of career. I have, since last year, I've taken up the position of Associate Dean for Research in College of Engineering, which is sort of an elevation from just computer science. So I'm overseeing the research activities of the entire college, which has 7 departments, including computer science and engineering. And I'm also slated to be the director of Big Data Analytics Center at UTA. So that's hopefully going to happen sometime over the next year or so. So that's my introduction. And at this point, I'll turn it over to the session chair for, I guess, the next round.
Okay, yes, thank you, Dr. Gutman. And okay, so I was very interesting, and actually, I think we are about to move on to the next phase. There are going to be 2 very general questions. So, okay, so what are the possible career options after the PhD or graduate study, and then how to choose them? And that is one general question. And second thing is very specific to our time now, how to better prepare for the uncertain job market that is highly affected by the corona pandemic. So I think those are 2 general topics that we want to spend some time discussing. From this point and onward, I want to hand over my mic to Dr. Clifton, who is going to moderate the session. Then I will later come back. I will looking at the questions and any kind of the questions from the chat and Slack channel. Later, maybe I think we have a time until 12:30. So I will come back around the noon, and then I will ask you questions that came up from the students. I think, how do you think about that?
Sounds good.
So
Okay.
do you want us to give some presentations? Or
Yes. Actually, I think the Dr. Clifton can moderate the talk, and you can take a turn, and you can also share your screen to efficiently deliver your messages to the students.
Okay.
So,
Yes.
okay, well, I will start out and just to give an idea of my understanding of what we're being asked to do here. Is I will start out by talking a little bit about post-PhD career options. And I'll keep it short because I know we've got a lot of people who have a lot of good experience. But I'm going to talk about 4. The academia and corporate research are probably the most well-known, but government and corporate development have a lot to be said for them too. So, in academia, what are the pros? Well, the big one is flexibility. You really can do what you want to do. And the other thing is variety. You're doing so many things at once. You're teaching, you have multiple research projects, administrative duties. And of course, the students. Working with students is very rewarding. Just seeing how people advance. These are some of the best stories of my career, looking at students and how they've succeeded, both undergraduate and graduate. I mean, you've seen, you've been looking at one of my students quite a bit the last few days, since he's one of, Professor Cantargialo is one of the program chairs. Cons, overload. Academia, there is so much to do and so many things to going on. It's hard to know when to say no. You have to really learn to say no, or you'll find the hours you're putting in are ridiculous. I work a lot more hours in academia. I have the flexibility to work them when I want, how I want, but there's so much to do. And students, wonderful, but also very demanding, asking a lot. Contrast with corporate research, the research labs, the resources you have in corporate research are much better. The teams that you form, where it's really, team of high-level people, and very exciting, a lot that comes out of that. And the focus, the ability to really spend all your time working on a particular research project it lets you get so much done. At the same time, you have this clear mission, corporate mission that you are expected to support. And that lessens the flexibility. And the very focus also gives you an intensity that can be very tiring, spending all your time on one thing. Just to quickly talk, what people often don't think about is there are a lot of jobs in government. Not just NSF, but many branches of government have opportunities for PhDs. I've been doing a lot of work recently with people at the Census Bureau. Pros there's stability, there's a clear mission, you know what you're doing, you know what you're trying to accomplish. And I found the collegiality at NSF, at Census, at other places to be really stronger than I've seen anywhere else. Something that might surprise you, but it's very true. Cons, lack of variety. That clear mission goes on for years, and you're basically working on very similar things. And you don't have the research flexibility that you do elsewhere. Finally, corporate development type of positions. They're, pros, you have real problems, real data, real resources to work with. And in particular, in our area, having that real data gives you the ability to build things and do things you just don't see elsewhere. Cons, well, research isn't the mission. And I'll talk more about this in Korean, what to do in this kind of recessionary phase we're in right now. This can pose some problems if you can get stuck in corporate development if you're not able to keep your research active. So anyway, I'm going to turn it over now. That's just some things as I see them, but I'm going to turn it over to Dr. Das and let him fill in for a bit what he sees.
Yeah, sorry, folks, I'm just trying to organize myself. So I need to share my screen again. Okay, can everybody see my screen?
Yes.
Okay.
Yes.
All right. So I have prepared a few slides trying to describe, in my opinion, the different career options and the pros and cons of some of these career options for a post-PhD career in computer science. So, as Chris has already mentioned, they really can be broken down into these, I guess the sort of 3 or 4 main groups. One is academia. One is research labs. I've clubbed them together, industry and government, but I think, and as Chris said, they really should be different because they're very different in their flavors. You also can go to product development and engineering positions in large companies. The 4th category, which we haven't talked much about today, is startups. And I don't think I'll be talking much about it simply because I don't have the right experience in that. And of course, finally, you've also got other careers. There are people who do PhDs and they just go back and join the family business, which could be completely different, or do other stuff. So my focus is going to be mainly on academia and industry research labs because I've got experience in both of those, and a little bit on product development. I've got, as I told you, a fairly short experience at Tandem in the late 90s. So factors which I believe are important for you in choosing a career, I've listed them in red. I think the first important thing for me has been passion. I mean, it really is, you should pick a career which you'll feel passionate about, and that should really kind of resonate with your sort of inner desires. And I'm not telling it in a cliched way. I think this is very important. You can go to a job where you can be unhappy because you're not kind of doing the thing that you are most capable of, for which you get the most enjoyment. So I'll talk a little bit more about passion, but I think it's a very important point. Then the other parts is, working in a career where you can have the greatest impact. And impact is something which is sometimes easy to measure, sometimes difficult to measure, but it is important for people. Resources are very important for doing research. Unless you're a mathematician where you only need pen and paper, most of us need resources, and some careers give you more resources than others. Independence, flexibility is also very important. Most of us are independent researchers. We like to sort of do things ourselves, so you need to worry about that. We also live in a connected world. Collaborations are important. Some of us are very dedicated to mentoring, and we feel very good when we are also teaching. So those things can play a role. And finally, there is this 800-pound gorilla here. I mean, compensation is also important. Different careers give you different compensations. Maybe, over the next 30 years of your career, you have to kind of figure out where you'll be making the most sort of value for yourself. So I'll just go a little bit deeper into some of these based on my sort of experience over the last 30 years of working. Passion, you really have to ask yourself, do you really want to be doing things which are path-breaking in terms of fundamental research? Do you want to be working on products that can be used by millions of people? Or is your passion really to sort of mentor and teach? Or it could be whether you want to make money. So you really have to ask yourself these very blunt questions. And both academia as well as industry will allow you to follow your passion, but with varying degrees. And maybe when I give the rest of my presentation, it'll become a little bit clearer the differences between them. Impact, industry has, in my opinion, the possibility of directly impacting millions of people. Because if you're working in a large company, like let's say when I was working at Microsoft Research, we were working on products, not me, just everybody, that were really used by lots of people. And your research can have a much closer path to this kind of impact as compared to academia, where the impact, the path to impact is a lot longer and less direct. Most of us in academia usually, write scientific papers, or at the most build a proof of concept kind of a prototype. And for that to be eventually, tested out in the real world, there is a long process, and many of us in academia are not into that. However, we might do something which may see the fruit of success 10 years from now, 20 years from now. So the impact is less direct, but it's still possible. So this is something you need to weigh when you're deciding. Resources. Industry usually gives you more resources. A large and established lab, lots of proprietary data sets, generous computing infrastructure, real world software systems where you can take in your own builds and make changes. So those are always the good things about industrial labs. Human resources are expensive. I remembered when I was at Microsoft Research in Surajit's group, a lot of things we had to do ourselves. We didn't have an army of students, working cheaply for us. At the most we had software design engineers, who were loaned out for this sort of prototype work, but most of the time they were involved with more mission critical products. So human resources can be very expensive in industry, and you have to rely on summer interns and that kind of things. In academia, data, computation, all this sort of resources are limited. You do have access to clusters which are shared across university systems and all that, but in general, resources are limited. But of course, one of the best resources you have is your PhD students. I think that has been a big differentiator, in my opinion, in terms of having a group, quickly building up a group where you can research. This is an industry where it's much harder to build a group unless you're a research manager like Surajit is. Otherwise, you'll be an individual contributor and you have to do a lot of things on your own. Independence and flexibility. I think this is, this is not a very debatable point. Everybody knows it. In industry, as a junior researcher, you're going to be assigned to a team and a project. So, yes, you will be told that, you can dream of your own project, but eventually, you have to worry about the bottom line of the company, and your work has to be aligned with the company's main business. A very, very sound and practical way of doing research in an industrial lab, and there's no way of doing it differently, but that does curtail your freedom. And there's going to be a lot more direct supervision of your activities. You will have a boss. I had a boss too when I was at Microsoft Research. What you're doing. In academia, you're on your own. You have a boss, like a department chair. Once a year, he or she is going to look at your annual report and sort of figure out a few things. Okay, how many dollars you got in, how many papers you wrote, but that's it. You are a principal investigator from day one. That's got its pros and cons. The pros is, you don't have somebody telling you what to do. The cons are you're lost. Unless you have a very good research vision, nobody's going to help you. You'll have a few mentors telling you a few things, but by and large, you're on your own. You do have a lot of flexibility, and that is unparalleled. You can set your own schedule. The summer months are always great. If you have grants to support your summer, you don't have to teach. You can do collaborations with other people. You can visit, and all of that is simply unmatched in industry. Again, I want to also mention that, academics is independent and flexible, but, you've got to be careful not to do research that you just feel like curious about. You really have to worry about funding trends. I think Vaishyan is going to tell more about that. So you have to balance that kind of research goals with what is fundable, because increasingly academia expects funding from junior professors, and this is something you need to be very, very careful about. Ability to collaborate, I won't dwell on it. I've already mentioned a little bit more, but I think there's a big difference. In industry, you're really collaborating within your company. You are collaborating with your team, with your product groups, especially for a large company. That's really the important set of people you are collaborating with. Yes, you also do external collaborations, but that is, in my opinion, based on my experiences, not as valued as the collaborations that you do within the company. In academia, unless you have administrative positions such as I do right now, your external research community is really the most important network that you need to build. Your reputation and impact in this community largely defines your career success. And that's really where you should be making most of your collaborations. And they're easy to do, they're encouraged, and there is really no comparison between industry and academia in this respect. Teaching and mentoring, industry, very little options to teach. You can go as adjunct professor in a nearby university. You of course have summer interns that you want to mentor. Teaching and mentoring opportunities, and this can be very rewarding for some people. As you saw a slide I put earlier, I'm so proud of the people that have been graduating from my group. And this is something I probably could not do as an individual contributor in industry. And hopefully, my students, former students, are also proud of me. Compensation differences. Everybody knows industry and academia. The differences is quite substantial, especially if you start getting to the marquee companies in industry. They can pay a lot more. Said that academia compensation is comfortable. None of us are starving, and there is something about stability. Eventually, when you get to tenured positions, and you're working for a university which has generous benefits, they can make up for some of the shortcomings. And I just put this at the very end because when I look back on my career, 30 years of working in both academia and industry, I don't think this has bothered me as much as maybe when you're starting out, you might be doing calculations as to where I'll make more money. I think other factors besides compensation are more important. And maybe that's the reason why you decided to do a PhD in the first place. If your objective was to make money in the first place, you probably would have selected a different career than research. All right, so that's all I had to say in terms of, maybe some of the different ways in which you can decide which career is best for you. And I will stop with this.
Well, let's continue with Wei-Shin, who can hopefully give us some additional thoughts on this question of options.
Sure. Well, actually, Dr. Clifton sent us his slides last night, so I had a quick look at it, and I realized that what he wanted to say, just like a superset of my answer. So he already gave us a lot of details, and I also got a feeling from what I heard from Dr. Das. So I just want to add 2 points to what they already told you. So the first is that since I'm kind of from the government, so I just want to remind you, the country has quite some national labs. So you may consider their positions. So they hire PhDs, and some of the jobs are quite interesting. So I know some of the audience are international students. So you may consider mainly academia and industry, but also consider national labs. They may have interesting jobs for you. The second point I want to say is that when you make career choices, like the options you have seen from the slides of Dr. Clifton, I would say you may also want to consider what kind of life you want to have for the future 20 or 30 years. I think Dr. Das kind of covered that. I think that's also important. You need to think about, how you are going to balance your life and your career. If you already have a family, then that's also an important factor, right? So I think when you have a number of offers in hand, could be from universities, could be from companies, you also need to consider what kind of life you want to have by yourself and also with your family. So say, for example, if you want to have a flexible schedule, then maybe academia is a better choice, because if you go to a company, then you may not have that much flexibility like what Dr. Clifton mentioned earlier. So that's basically what I want to add, my 2 cents.
Thank you. Sergey?
Yeah, okay. Can you see my screen?
Yep.
Okay. Okay, so I'll come back to the question, but I thought having spent more than 20, almost 25 years in industrial labs, I should first tell you a little bit what I know best about the life in industrial labs. And my personal journey, what I'm going to say mostly, given that I've been 20 plus years in Microsoft Research, is obviously my view or my experience at Microsoft Research. I think that the advantage of industrial labs is you can actually do curiosity-driven research, and you can openly share it with the research community. This is something you can, of course, do in faculty. But I think that, as we'll see in a second, this independence is very much preserved in industrial research lab. To correct a small aspect that Gautam said is, whether you believe it or not, even though I'm the manager of the group, I do not get to directly tell the researcher that thou shalt work on this project. The reason is very simple, is I'm not their PhD advisor. My role is mostly to advise them, give them perspectives on a problem they're considering working, and perhaps to encourage them to talk to other people. Beyond that, certainly in Microsoft Research, I cannot and will not have more influence than, to decide what projects they work on. And I think that's fair, because in science and engineering, if you have to take your cues from people as old as me, that would be pretty tragic, right? So, and I think that that's something I wanted to call out, that at least in Microsoft Research, that's not how it works. What we do have is to have the opportunity and the necessity to rely on the excellent colleagues that you have. We do not have, as pointed out already, that we do not have PhD students. We have colleagues. So when you want to do something substantial, joining forces with your colleagues is, I would say, a very good thing. Yes, you can go alone, but it will take you longer. It may be even frustrating because you think that you have a great idea, but not enough people are joining. And the resources, while we have some to inject in a very promising project, there is never enough to support everybody's need for research developers. So the best asset we have is the current pool of researchers and research developers, and for people to independently come together and work on projects that they enjoy. So if you ever are going to be hired in industrial research lab, you want to look at the people there. And apart from other things, you want to ask, are these the people I want to hang out with and brainstorm about research projects? Would I learn from them? Would I be interested in doing research projects with them? So the colleagues matter a lot in industrial research labs. One of the great benefits of a research lab such as MSR is you can learn from the experience of great engineering teams. Microsoft SQL Server, in general, our data platforms, big data platforms, and many other Azure infrastructure, the cloud infrastructure, has some excellent engineers. Moreover, and I think this is no credit to Microsoft Research or any other database industrial lab, but goes back to the great tradition that in database systems was set up by Jim Gray and many other founders of our field, is that the industry and the research community are actually very deeply interconnected through conferences such as data engineering, SIGMOD, or VLDB. And our engineering teams are actually very aware of some of the research innovations. Not everything, right? I mean, it has to be something that they can relate to. But they're very open to the research ideas, and they are very well educated in the recent advances in research. So you may think, oh, these people do not know anything about algorithms. But the reality is today, hyperlog is in almost all, the sketching algorithm is actually in almost all data platforms. And that's because they recognize its value, right? It has come to a point of maturity where it can be adopted. So they're very well conversant about figuring out what, possibly can be useful from the research world. Learning from them is also to understand what works and what doesn't work. They have got a wealth of experience that we can lean back on. And this is a unique opportunity in an industrial research lab that's very hard to match elsewhere. I think Gautam mentioned this, that there is access to telemetry and customer engagements. So the so-called the exhaust that we generate in a cloud infrastructure, the telemetry part of it we can watch. I want to clarify that while being the query logs are visible, the same is not true when you sort of sign up for the cloud infrastructure. There is a requirement that we can drop a program inside the compliance zone to observe or analyze, but we cannot openly see how you're using Microsoft Office or how you're using Microsoft SQL Server for your enterprise applications. But that said, there is a wealth of data that we cannot even share with you, even if you wish to. And so this is a very, very big advantage of industrial research labs. And while no success is guaranteed, because if you have a 100% hit rate to impact our product, that would simply mean in our research labs, we are not taking ambitious enough projects. But from time to time, we do have success in impacting our products and services. So if you look at our bosses in industrial research labs, such as Microsoft Research, how they look at us, they ask us, are we taking sufficiently big bets? At the same time, from a very realistic perspective, over a 5 to 10 year period, you want to see what the strengths of your corporation is, and you want to leverage those in a selfish way, right? And so because that's where you can learn from the rest of the ecosystem of the company, and you have a hope of contributing. But I think the other, nobody should equate the industrial lab, research lab with the goal is, well, just can you help out in the next release of a product? Honestly, if that's the goal, then keeping a research lab is not worthwhile. You might as well merge that with the core industry, because your resume is not going to speak to anything different. Just by saying you worked at Microsoft Research will not help if all the time you're helping with the next 6 months of Azure or SQL Server. So one of the benefits we have is learning from failure. So for example, in the first round, when I worked on and I've failed many times in many of the endeavors. For example, it has been, many years ago, probably we are, and Gautam and I have a co-authored paper on, searching for data objects in structured data objects. And over the years, I've realized how hard it is and why it is hard. Why it is hard for this to become a reality. Why doing any effective ranking there, an interpretation of what the result of a search terms on structured data is much harder than that, over document stores. I've learned why approximate query processing is more difficult for adoption. It's almost like saying to an industry, if you say, I want to give you some help and you have some amazing ways to tune a model, but you have to keep retraining a model. The bar is so high that in many cases it would be untenable unless the need is superb. So you're brushing with the rest of the engineering ecosystem, and you're trying out things that are far out, but the industry actually looked at it carefully, gives you amazing perspective, even from a research end. Gautam's first slide was very interesting, and I think I would want to return and re-emphasize the point. What is important to you? I think before you say, because Dr. Clifton already laid out your career options very clearly. What are your dimensions in which you can go? But I would say your work kind of starts well before that, to know yourself. Is independence important to you? Or you're happy to work on an ambitious project that may have been defined for you? If you're happy to work on an ambitious project that has been defined for you, today's industry, unlike when I graduated, provides a lot more innovative work. So industry of 2020 is actually, there are some really far-flung ideas that are being incubated in the industry, be it a startup or be it in the core industry. So if you do not care deeply about independence, you have many options to be part of very exciting projects. And these projects will change over time. This is for not lifelong. But if you have the curiosity and you're happy to join a project that sparks your curiosity or feeds your curiosity, you can find those. They may not be everywhere, but they're there. Don Knuth, when one of my friends was thinking about going to faculty, asked him a question saying, you don't have to enjoy it supremely, but are you happy doing teaching? Because it may not be the main criteria for your evaluation in faculty, but this is something you got to not hate. And I had the opportunity, as Gautam said, Gautam and I worked together for years. He's a fantastic presenter, and he can explain very well, and I can see how he would be a very effective teacher. So I think that you have to love at least part of it, and of grooming students, and to be able to teach, and not look at it as a complete burden. To get to a research, be it academia or industrial research, you have to deal with ambiguity. And this is what I contrast with the first bullet, that if you claim that you want independence, you better deal with the frustration that the problem specification is unclear. You don't know whether this problem is, is this really a problem, the right problem to focus on? Because in research, the choice of the problem is far more important than the specific algorithm. The chances are you may not have the world's best algorithm, but over time it will get refined if your problem is interesting. My advisor said something really interesting that first shocked me. He said, the proofs of a theorem is not important. So everybody in my research group was like, what are you saying? Proofs are not important. How can that? He said, well, look, two things can happen. Either your result theorem is so interesting that other people will follow through. And most cases, they're going to find the flaws in your proof. And I think otherwise, if this result is not interesting, the theorem is not interesting, who cares what the proof is, right? I mean, nobody cares. So he was really making the point that what you work on is really important. And I think that I want to emphasize that, but it means that you will have periods of frustration where you don't know the problem you're working on. I already talked about mentoring. There are other things, that are very personal. Why would you like to live? What excites you? what is your measure for success for yourself? I mean, Gautam is absolutely right. I mean, if you just focus on compensation, the answer is crystal clear. Either you go to the industry direct, and probably you should not have done a PhD, or you can join a startup and, you know, take a gamble, and the gamble can pay very well or may not. But I think that this is the crucial point. What is your measure of success? And you have to live a life before you count your dollars, right? So you have to be happy with every day, with the decisions you make. And the main thing I would say, which probably hasn't been said so far, is that don't try to decide for your entire life. That's too overpowering. And honestly, until you experience something, you will not know how it is. You may think you really want independence, but maybe you get very frustrated with not having the right problem specification or having the right, you know, scaffolding around it within which you operate. So think in next 3 to 5 years, think of the first step, you know, in the journey, because some of the steps are reversible. You can change your mind, not everything, but I think that trying to think where I would end my life, and I must decide as one way how I should go, and there is no backtracking, is very hard. So think next 3 to 5 years, and I think not only in the first step in your journey, every 3 to 5 years you will have to go through and reflect on, am I at the right place? Do I need to change where I am? So my main suggestion would be, while at school, do industry internship. This is super, super important. It is important for an industry hire. It is important for you to get a sense how industry development works. It is important for industrial research. At least for my group, I can say about 80 to 85% of all the people I've hired over the 20 plus years are former interns. So not doing industrial internship or industrial research lab internships is a huge mistake. And by doing this internship, it will also tell you, do you like the industry? Yes, you are not going to get the clearest of the picture what industry involves, but you'll get having some flavor.
Surajit, seems to have we've lost audio, I think. Are other people experiencing the same thing?
Yeah, I can't hear him either.
Okay. Well,
yeah, he seemed to be disconnected.
Okay.
Sure. Yeah.
How about if we move on with Wei Shin answering our third question, which is how to prepare for the uncertain job market that is resulting from the COVID-19 experience?
Well, yes. The answer in my mind is that I think certainly one choice is to talk to your advisor, since the person knows you very well, right? So your advisor knows your strengths, your weaknesses, and he or she may have some options in hand already. So I think certainly one option is for you to stay for 1 or 2 more semesters, right? In case you cannot find the ideal job on the market. I think that's likely for the future of a few months. But you know, you can use the time to make yourself, your CV more competitive, right? So if you want to find a job in academia, I think you can use the time 1 or 2 more semesters to write a few more good papers. I think that's a way to make yourself more competitive. Then when opportunities come, you can certainly pursue whatever you want to get. And I think another option is to also search for postdoc positions. I think you can also ask your advisor to kind of send your CV to his or her friends. Your advisor may have contacts, and those people may want to hire postdocs. I think that could be an option if you cannot quickly find a permanent position under the current situation. So I think those are the options in my mind. And For ASF, I can say that we are aware of the current situation. So we may have some solution to help PhD students who are going to graduate this summer. So you may want to check ASF website, or especially the science directories. That's where I am working. So we may have some programs to help students, PhD students who are going to graduate this year. So anyway, for ASF, we are aware of the situation. We know it's not an easy time for you to find a good job with a PhD. So that's my suggestions for this question.
Okay, Gautam?
Yeah, so let me share my screen. I have a few things to present here. Okay, so I think we already heard some very good ideas of how to address the current crisis that is playing around. You know, there is a lot of challenges, right, for getting a job in this current environment. You know, in some cases, graduation timelines are getting delayed. You know, there have been hiring freezes across industry and academia. And although that's not true for all industries, essential industries and services are probably seeing an uptick in the kind of jobs that are out there. So, you know, for those people whose research aligns with that kind of essential industries may actually be in a better position than some of the others. And more broadly, I think computer science jobs, since they can be done online, you know, we are largely spared of some of the challenges that maybe other professions are facing. You know, teaching has gone online. A lot of computer science research can be done remotely. So, and also, as I mentioned, you know, industry and academia might actually increase or consider increasing hiring in specific areas such as online education, immersive technologies, virtual reality. I know that at UTA, we are starting to look more closely at these kind of areas in our strategic plans. You know, putting more emphasis on research that is connected with disaster management and mitigation. All of these are going to become more and more important for the future. And if your work is aligned in these, you're actually better off now than perhaps you were before. The other challenge is, you know, the interview process has changed. You know, instead of in-person interviews, we're getting into online interviews. So I have a few practical suggestions to suggest here. So my couple of slides are going to talk about that. So how to prepare better? I think most of the standard advice still holds. You know, you need to do a good PhD. Your research should be good. You should have good publications. You should network well. You know, I mean, if you reach out to potential recruiters, that always helps. And I can understand that it's a little challenging right now because we don't have in-person conferences. For example, ICDE normally would have been a great place for networking because you'd have gone around meeting people, you know, going to some of the industry booths, talking to folks. So we don't have that. But somehow or other, you need to take advantage of the way the online conferences are being held and try to increase your networking presence to make sure that recruiters, those who are hiring, you know, see that you are around. And I think preparing for online interviews is something that requires a little bit of practice. And those of you who are in colleges and universities where they're career centers, you may want to look up ways in which they are offering advice for how to conduct virtual interviews. I think you'll be impressed and amazed by the amount of you know, thought that has gone into giving such advice. And I myself did not know about it until I attended one of these career fairs, you know, just out of curiosity. Your job talk is going to be now done virtually, so you have to prepare it well. You know, do a lot of good dry runs. For example, right now I'm giving this talk through this online medium. I can see that I'm doing things which I could have done differently when I was doing an in-person talk. the body language has to be different. It shouldn't be, normally you dress up more casually. It's my mistake. That way Chris has done a good job today. So you got to worry about, how you come across virtually and make sure that it's very similar to how it is in-person interviews. And if you're looking for an academic job, if you already have some online teaching or online research experience over the last few months, it'd be a good idea to talk about that, because I think many of them are looking for these kind of experiences. I mean, all of us went into academic teaching in a very, very disruptive way, and many of us are struggling, and those of us who had some prior experience are actually better off. So if you have some of that prior experience, you should certainly talk about it in your interviews. The other challenge most of us who are looking for a job will face is that, it's kind of important to visit the city, the campus, and all of that before you kind of decide, right? And this becomes very tricky. So all I can suggest at this stage is, if you go through a online interview and you just got to look up images, videos on the internet of that environment, the campus, your colleagues. After your interview, if things get serious, you may actually request for these things, maybe one-on-one meetings. As Surajit mentioned, when you're joining a research lab, it is very important to know your colleagues. It may not be so important in academia because you're sort of on your own in academia, but in industrial labs, it's very important to know your colleagues. So you may want to actually have in-person meetings if things get serious, to get to know your potential colleagues more carefully, simply because you haven't made that physical visit. Negotiations, once you get an offer, is also tricky because most of us are kind of wondering can we really, be assertive in what we want? And we don't quite know what the market rates are. We knew it 3 months ago, but right now, are there declining jobs, and is it a glut of applicants? We don't quite know, right? But I think for CS jobs, there hasn't been that much of disruption, certainly not for the case of UT Arlington. All our approved CS faculty jobs are still there. We are still hiring. I think there's going to be a freeze for future jobs, and probably rightly so for cost containment measures. But whatever jobs are out there, which are already advertised, we're going to go through with those. You may want to consider longer timelines for, exhausting startup packages, maybe get teaching reductions longer, because I think online teaching requires a lot more preparation. So you may want to request for extra time for that. Student recruiting, sometimes the startup packages tell you that you've got to have the students for the next 2 years. You might want to say, can I have it for 3 years? Because it might take you a little bit longer to recruit students. So anyway, so these are some of the practical advices I can give. I'm going to stop with this because I'm sure the other panelists will have many more things to say. And we also want to give the attendees a chance to ask questions. So that's all I had.
Okay, thank you. I'm going to just go very briefly through and try to answer some of the questions that have been brought up as I'm going through this discussion here.
Actually, just wanted to say that I'm back online.
Okay, yeah, Sergey, so let me go through a couple and then I'll let you go and you can answer some of the additional questions. So, people are talking about, the world has changed. Well, yeah, there's been some significant changes. Searches, I've heard of searches being stopped. Academia changing forever, talks about, how do we, is online learning taking over? Well, I'd like to point out these aren't new discussions. It's just all of a sudden it seems to have more impetus. What uncertain job market? Purdue CS, a lot of other places haven't stopped the searches. They've changed, but they haven't stopped. Hiring freezes aren't new. Several of the people you're looking at got their jobs in areas when a lot of people were their first jobs in times when there were a lot of hiring freezes going on. Waited out in postdocs or less than optimal position. You've gotten some good advice on that. Postdocs can be valuable. Even we have a number of people who have gotten a job offer from us and then delayed that offer to do a postdoc. and come join a year later. Perfectly reasonable thing to do and can be very valuable. Now you just have the option of doing that without maybe the certainty of a job. Expect a boom. Computer science isn't going away. The boom will resume and there'll be a pent-up hiring demand. Be ready for it. Key thing to remember, we're the ones enabling all this change. As was pointed out, be ready for the online learning. Be ready for online interviews. More and more, the first round of interviews is being done online. You got to be good at that anyway, COVID-19 or not. So a lot of the advice that you've been getting about this is not just COVID-19 world advice, but it's general advice. So I'm going to turn it over now to Surajit, who's rejoined us.
Can you tell me what is the last you heard me about?
It was the beginning, about halfway through your I think, slide, slide 7, farther.
Okay, the next one maybe.
Next slide.
Okay, this one?
Yeah, we'd heard, it was about halfway through this.
Okay.
But please try to go quickly because we've already used up almost all of the time allotted for questions.
Sure. So I think the important thing, if you heard me, is that doing industry internship is very important, both for industry and the industrial research lab. That's crucial for you to eliminate options or to love that option or to get a flavor. Faculty and industry seems are like very broad categories with very less variance perhaps in the basic operating principle. And if you prefer startups, my suggestion would be that unless you are a startup founder, which is a very exceptional scenario, if you're just joining a startup, you may want to consider starting out a few years at an established high-tech regular development job. The reason is it will give you a great footing in the industrial practice of software engineering, how to use repos, and you'll learn a lot of practices which will be helpful even if you decide to go to startups. So I wouldn't underestimate that exposure, even if your eventual goal is to lead a life of a serial startup. Industrial research labs. I'm very proud of MSR. In some ways, it operates to the close proximity to Bell Labs in terms of giving you the independence and, at the same time, having the ability to work closely with the engineering team to take your innovation to the reality in some cases where it is feasible. But industrial research labs, or what are called labs, come in very different shades. So I think it is unlike faculty and industry where there is broad understanding on how it operates. You really need to understand the culture of the specific industrial research lab. It's not enough to read the label research lab. The other thing to keep in mind, any research lab, and I'm not excluding Microsoft Research from that either, could potentially change over your career because it depends on how the mothership is doing. If Microsoft is doing very badly today, it is possible that the research culture would change. Right now it is doing superbly. And it has sustained so far the research culture without any changes, but it could change if the mothership itself is threatened or go through a leadership change which is drastic. But the way to think about it is go back to what I said in the last slide. Don't think about your entire life. Ask, will it help you for the next 3 to 5 years? Because it can be a very effective career step to understand both the industry as well as have the ability with a low overhead to bootstrap your research that you are good at with great colleagues. You have unique access to data and customer. One thing I would say, too early in the career, do not get tempted by becoming a research manager of 3 researchers. The danger is you get, in the process, degrade your individual research capability. That would be lethal because I'll just say this, as a research manager, perhaps other than taking a position in the dean's office, there are not that many jobs for a research manager, okay? So as an individual researcher, like tomorrow, if I have to change a job, people would probably hire me because I know something about the database systems. They're not going to hire me because I have been a research manager for, so many years. So don't get too, feel that research manager is particularly attractive too early in your career. I want to remind you that transitions happen all the time. This is why you don't think of your entire life in one shot. From Brown University, just 3 months ago, we had a faculty join MSR. From MSR, folks who are in 3 to 5 years in MSR have gone to Harvard, MIT, CMU. Not CMU, Harvard and MIT. Not everybody is going to make it to Harvard and MIT. This is not an average case, but transitions happen. Janet Wing joined us from Microsoft Research, and now she has gone back to Columbia. Right. And, so these transitions happen. You have to manage the transitions carefully, and we'll come to that in a second. From Microsoft Research or industrial research lab to go to core industry is extremely common. It is probably the most popular path that many people will take at some point in their career if they want to decide to go. Like from MSR, people who have gone to Microsoft Azure, AWS, or Google, many, from my research group even. From faculty to industry is all the time has happened sporadically throughout their career. Gautam has done it. You heard from Gautam, and he has gone back to faculty. Industry to faculty is less common just because the industry exposure does not give you, unlike industrial research lab, the ability to publish and keep your research profile up. So that one is a harder one to transition back through, and you should be careful about that, right? Industrial research, a good industrial research will still allow you to keep that as these transitions show. I think perhaps the most important thing is that whether it's your department, whether you're a research manager or your university is not going to manage your career. It's the most important thing to keep in mind. You should manage your own career and transitions. What you value really matters most. But what you value today may not be what you value 5 years from now. This will change based on your experience, based on your needs, ask, and many other factors. And we see this all the time. And finally, the environment will change, around you. For some, this could be, there is so much more I can make in industry, or it could be the degraded, focus of the particular institution you are in. If MSR tomorrow starts behaving like it's just a industry named as Microsoft Research, many of the researchers would leave, and rightly so, because their aspirations won't be fulfilled. So if the environment changes, around you, you have to watch out, and it's specifically true for industry, industrial research labs. Faculty is probably more stable in that regard. Industrial research labs have been, like Microsoft Research has been very stable, but you must see whether your ambitions are being met there. The last point about the uncertain job market that is being discussed is recessions are cyclic. I too graduated, at the height of recession, and I asked Hamid, who was at IBM Research, because I used to work in query optimization, if there is a job, and he said there is no job. I really wanted to stay in the Bay Area. I took a job in HP Labs, which was not as important a research group as IBM Research then was. But I think you have to go for the best possible choice, but keep an eye towards that doesn't compromise you. Just because something gives you a little more compensation, you don't want to compromise if you really have a dream of, taking your career somewhere. So a university or even an industry postdoctoral position, which are easier to fund, certainly in industry, than a full-time job, permanent job, is something that you should consider. Potentially a less desirable industrial research lab, and likewise for faculty positions. And in faculty or in industry, people have always used the upswing in the economy to transition out to an upgrade. That's common sense. One interesting fact I would say, if you go back and look when Google was founded, it was actually founded, or started growing up in the depth of the recession in the late 90s. So what this startup does, what it happens in such a downturn is the hype around many of the startups is removed, and there is a lot more critical looking into the value of the startups. So if you have a passion for an area and if you get a startup offer, I would not necessarily turn it down if it would be good experience at the very least. Because for all you know, there may be some important startups born out of this, the kind of the bad scenario. And I think my last thing is, don't try to be so overburdened with making the right decision. Try to enjoy the journey and keep an eye on the road. That's all I would say. That's all I have.
Thank you, everybody. So yeah, I just want to remind you that we just 5 more minutes to go, and there are tons of questions came up from the chatting windows. If you could take a look at, there are very interesting, real questions about what do we have to be prepared for, industrial labs, how easy it is to switch over the research and industry and back and forth, and then how helpful I think spending a time as a postdoc is going to be. There are many questions. So I think we only have, I feel so sorry that we only have 5 minutes to go, but I think let's try to do some kind of free discussion. And then if you can spend some time answering them by chatting windows, that will be also an option, I guess. Yes.
Okay. I think I'll just start with this first one, how to position yourself for your first job. Academia, do good research and make sure that you can communicate that research well. Be able to present well, be able to write well, and that's the key thing, I think, for academia. Industry, there's others who can really talk more about what really makes the difference in getting a good industry position. I'll let them speak up on that.
Well, I think that in an industrial research lab, just to call that out, is when you join, try to understand what is going on in the project. Don't just try to come and say, I will do my own project. Yes, you have that right. But by doing so, you may not know your colleagues. You may not draw upon their strengths. And by joining an existing project, there's a thrill in seeing the project progress with your help. So I would say, don't become too individualistic on day one. There would be time for it. Get to learn the system where you are living. And in the industry, when you are in a particular position, like changing within a large corporation is super easy. It's not going to be that easy in a startup. So you're not locked into there. When you go there, try to be productive so that people respect you as somebody who is productive, has high quality technical contribution. And I think, building that reputation of being that you work well with others, as well as deliver, the products or research well, is the reputation you want to build in the first few years.
Let's see. Another question here is talking about, money income dimension and potential to make more money. There's been some discussion of this, but I'd like to point out one thing. Think of it not in terms of how much money am I going to make, but what lifestyle am I going to be able to afford? I had a choice between going for a PhD or going to a pre-IPO startup. The pre-IPO startup was successful. 10 years later, I figured it out. Those stock options I turned down would have been $7 million. And, let me shut this up. It would have been $7 million. I am looking out my backyard at 7 acres. I don't see my neighbors, trees, woods. I've got my own park here, swimming pool, everything.
So you're practicing social distancing easily.
Easily. I could play baseball and social distance out here.
Where I'm living, if I whistle, my neighbors are going to come running, okay, because they're that close. It's like an apartment in India, okay? So.
Yes, I look at it this way. Sure, I didn't get that multi-million dollars, but could I afford a place like this on $7 million within biking distance of Oracle headquarters? At Purdue, I can. It's a lot of it is the places where you can make a lot of money, you need a lot of money. And a lot of places that you may have lower compensation, but you don't need that compensation to live as well or better. So keep that in mind when you're thinking about offers. Don't just look at the money, look at the benefits packages, look at retirement, and look at what it's going to cost you to have the lifestyle you want. So keep that in mind.
Cliff is right, but I think that there is one interesting point I would say. If you look at a company such as GitHub, GitHub is all virtual. There is no like one central office. And coming out of the COVID, you might see a bit of acceleration in there. It's just a related point. It is not crucial. So people may be able to live a lot closer to what they would like or can afford. So this will be interesting to watch.
Okay. Let's see, we've got a question here. How hard is it to shift among different areas, like between academia and industry? We've got several people who've done that. I've done it twice, to industry, then back to academia. You want to shift to academia, you've got to keep your research going while you're in industry and keep that research record, research visibility. When I went to MITRE Corporation, I was going to a place where they actually actively encouraged you to publish and keep an active presence in the research community. Many research labs do that, but not all of them. You hear people coming from some research labs into academia, but not all of them. And look and see how much those encourage you to publish and stay active in the research community. As far as moving to industry, there's probably others who can give me a better idea of the best way to do that. But that's often going from academia to industry. We've seen a number of people are very successful at that. And I think if you really have the passion and desire to be in industry after having been in academia, it's because you're someone who's going to be valuable there. But let some of the others speak up.
Yeah, so I just wanted to add one more, insight of transiting from industry to academia. I think in later years, when you're more senior, I think transition into academia, they really look at two things. One is, of course, your research. And the other one is also your visibility among the funding agencies. And sometimes when you're in industry, you may not have that. How often have you been connecting with DoD sponsors? How often have you been interacting with the National Science Foundation, National Institute of Health? Because these are the kind of funding agencies which are more common in academia versus industrial funding. So that's one challenge that industry people will probably face when they become senior, because a senior hire in academia expects that in addition to a stellar publication record. So that is something to be careful about.
I mean, I would say Gautam is very right in one thing, that if you say, there is a tenure track process in academia, right? Let's say you can only be considered because of your seniority as a tenured faculty. The bar clearly goes up, right? Sharply, because academia is writing a check for you without having checked you out, right, in their environment. So which means that they're going to be a lot more choosy. So in terms of when you want to transition out of an industrial research lab, and I'm going to distinguish between that and industry broadly, industrial research labs such as Microsoft, where you have the ability to publish and keep your publication record high, there is still a question of, that's what I meant by saying you have to manage your own career. The transition points matter, because if you go become more and more senior, the bar for that would be higher. It is not practical from an industrial research lab to keep any closer ties with, for example, funding agencies. It is not going to work. Most cases it don't work. And I think that, but if you started with faculty before and you have a track record for it, you worked in industry for a few years and you want to transition back in a senior position, that should help you a lot. But I think in a junior position, just having your research publications and visibility in the research community, in my case, our experience from MSR on people who have transitioned to junior tenure track or accelerated tenure track positions back to faculty has not been an issue.
That's true.
Okay, so hi everybody. So I'm really sorry to chime in, but I think I have to conclude the session now because we overused the time that we're given because it was so interesting. So again, my appreciation to the whole panelists for the great session and for the great advices that you have shared with us. So yeah, I think now it is time for me to conclude and then close the session. Thanks again. And yeah, okay. So yeah, enjoy the rest of the conference. Thank you, everybody.
Thanks, Hankook.
Thank you.
Okay,
Bye.
thank you. Bye-bye.
Bye.
Thank you.
Many of us are in the Slack session, so you can post some questions there. We can keep going for a few more minutes.
Yes, true. Yes.
Thanks.
Thank
Bye.
you.
Bye.
Thank you. Bye.
Bye.
Hello everyone, it's a great honor to participate in the ICDE 220 and thank you very much for listening to my presentation. Our topic is neighborhood density correlation clustering and I am Zhenggang Wang from China. Cluster analysis is a process of grouping a collecting of physical or objects into classes of similar objects. It's an important research direction. In our work, by analyzing the advantages and disadvantages of existing clustering analysis approach, a new neighborhood density correlation clustering called NDCC for quickly discovering arbitrary shaped clusters is proposed that avoid the clustering errors caused by isodensity points between the clusters. Because the density of a central region of any cluster sample dataset is greater than that of edge region, the data points can be divided into core, edge, and noise data points, and then the density correlation of core data points in their neighborhood can be used to form a cluster. The clustering result of sample dataset can be formed according to the connection between the core data points and edge points by constructing an objective function and optimizing the parameters automatically. A local optimal result that is close to the global optimal solution can be obtained. This approach solves the difficulty of parameter optimizing and clustering in separated clustering to some extent and has excellent potential for application in data analyzing and mining. The contributions of our paper is as below. By relying on adaptive distance radius to distinguish core, edge, and noise points, neighborhood density coloration is used instead of a real distance to measure the coloration between the core points. A operated objective function is adopted to minimize the distance between some core points, realizing unseparated learning. Different clustering approaches have their own advantages and disadvantages. By improving the shortcomings of this method, NDCC completely abandons the method of calculating the center within the cluster. Instead, it incorporated the idea of density coloration, but is not limited to density of a fixed region, and doesn't use a certain defined distance or a certain defined density as a measure of a differentiation between different classes. We take the key nearest neighbor domain of each point as an analyzing object, and consider each point and its neighboring key points as the same cluster data. When all points are divided into a certain number of clusters, a coloration process is completed. The method can detect aspheric clusters and automatically find the correct number of clusters. This method doesn't consider the influence of isodensity points between the clusters in cluster classification. Generation performance and robustness are improved. This figure shows the distance from each data point to other data points in the sample set is calculated to consistent the distance from the data points to all points. To determine the nature of data point, first a circle centered on the point within a radius that is equal to the mean of a distance to the mth point in the overall ordered distance matrix S is founded. If there is only one point inside the circle, this point is a noise point, and if the number of points is more than 1 and less than m, then it's an edge point. Otherwise, if there are more than m points, the point is a core point. As seen in the figure, when m equals 3, the red points are core points, and the green points are edge points, and the black is a noise point. After removing the edge point and noise points, the core points S ordered serial number matrix X0 is obtained. Moreover, the factor that interfere with clustering has been removed, which is more conducive to clustering the dataset. According to the shape of a dataset after removing noise points, as shown in the following figure, it's obvious that the relation between the clusters is weakened and is easier to distinguish different clusters. We can adopt different strategies with cluster sample sets into different number of clusters. When a compact strategy is adopted, a strong connection between 2 points is needed to classify them into one class. The sample set is hence clustered into a large number of independent clusters. When a sparse strategy is adopted, only a weak connection between 2 points is needed, and the sample set is clustered into a small number of independent clusters. All edge points are grouped into a nearest cluster of core points according to their distance from the core, different from other clustering approach that optimize objective function. The location of cluster each point is performed in a single step. On the other hand, it's difficult to find suitable parameters for clustering without sufficient primary knowledge and multiply trials. Through appropriate tragic function setting, our approach can automatically adjust parameters and cluster a dataset. Although the data points of a cluster group have some property to a certain extent, in fact, sometimes points with a relatively large distance will be grouped into one group. If we use the features of all points in the cluster to measure the clustering result, there will be a large deviation that can be avoided by using a local average density evolution model. We believe that the clustering effort of a sample set can be measured by density compactness of local points, and the local compactness of each point can be established by sum of distance from the data point to the adjacent points. If the ratio of sum of distance from each point of a sample set to the key nearest neighbor points and the number of clustering categories and the value of keys are small, the density compactness of local points is high. In this paper, this index is defined as a local density compactness coefficient called LDCC. The minimum value of LDCC leads to the best clustering results. This coefficient is used as a tragic function J to optimize parameters M and key. The equation of Jm is as below. Jm equals plus Dij divided J multiply Nkxp. Here J is a number of clusters and Dij is a mean of distance from each point to the key neighboring points. The optimal classification cluster is determined by the minimum local average density. The value of M is set from 1 to n and K is set to from 1 to n1, so that the whole clustering process goes from fine to coarse. When all the data points are grouped into a cluster, it suggested that for the current values of M and K, there is no efficient in continuing to increase neighborhood correlation. At this time, the value of K corresponding to M is fixed and M is increasing to continue the iteration to obtain different values of J. The minimum value of J corresponding to final value of M and K. The result can be considered as a local optimal clustering result, that is close to the global optimum. This table shows that the NMI, AR, RIMI, HI, and the time of various approach on 7 datasets. It can be seen that our approach achieves a good application. Clustering effort of various approach on 7 different datasets. We can see from the figure that our approach shows the best efforts. And this is the result for NMI, AR, and so on for different values of objective function J. On all datasets in general, when the value of objective function J is minimum, the best clustering results are obtained. As seen from the fig, the NMI and AR are reduced when the neighborhood points are increasing. This fig shows that NDCC approach on tech-free NWPU raises 45 remote sense dataset clustering segmentation efforts display. Our approach can find the number of image clustering in completely unseparated way. After all, in this paper, we propose NDCC approach, which is a clustering method based on local density of data points. Adaptive distance is used to distinguish the core points, edge points, and noise points, and the neighborhood correlation clustering is performed on core points. Finally, edge points are allocated to core points to complete one iteration. By optimizing the parameters of adaptive distance m and number of neighborhood points k and minimum the objective function, the clustering process of data points is completed. Different from other clustering approach, this method doesn't need the parameters to be set manually. The optimal value of m and k are obtained automatically by minimum the objective function to realize unseparated clustering of sample dataset. On the other hand, as the time of complexity of the approach is at a general level, the calculation time is relatively long when process extremely large datasets, for example, over 100,000 data points. For each data point, we focus on neighborhood points, so it doesn't make much sense to calculate the distance between the data points that differ too much. In future work, our aim is to optimize the structure of the approach according to the neighborhood characters of the data points. Omit the calculation of a distance between data points with large differences and attempt to reduce the time complexity of this approach. Thank you very much for listening. Thank you.
So hi, can cook. Looks like we don't have any questions for this this paper. Hi, can cook. Are you there? Hi, Aparna. Are you there?
Yes, Professor, I'm here.
Yeah, maybe I think I mean this is yeah so I think this is the end of the morning session. We extended 20 more minutes, but I think the panel went very well, and so hopefully the students can got very good information about career options. Maybe I mean I think Professor I is here, so I think the afternoon session will start at 1, which will be after 5 minutes.
Yes, sounds good.
Okay, cool. Thank you. Hi, Aparna. So are you able to find all the videos for the papers in the afternoon session?
I'm just not able to find the first one, Professor. I can ask the presenter to send the email, to send the link to
Okay.
because I cannot find the video presentation from the Excel sheet that they have shared with me.
Yeah, you can email it also. Because I think she said she uploaded a poster and the video. But yeah, you can just ask her to send you the link to the video, and in case you cannot receive the video timely, maybe you can ask.
I can make her the co-host and make her present it from her laptop directly.
So is the first one by Messay
yeah.
Avenue?
Yeah, that's correct.
So I think that is actually there. I didn't find it. Just a minute. Yes. So can you try this link? I'm just putting it on the chat.
Yes, Professor. Awesome. I got this.
It seems like some of them actually have two submissions, I think. So some of the submissions don't have the video, but some of them have it. So
I got this, Professor. I got the video. I think this should work.
Then how about other papers? Did you get videos for other papers?
I have the other ones, the videos.
So mean you have the videos of all the papers for the afternoon session?
Yes, I do.
Wonderful, good. Thank you.
You're welcome.
Thank you. So hi, Risha. Thanks for your help.
yeah, no problem.
Yeah.